Hello, everyone. Welcome to the practice set for lesson 39. Let's go ahead and get started. We're working with proportions today. Proportions, we're just looking at two ratios that are equivalent. You would say that they're proportionate because their value is equivalent, even though they look slightly different. Now, when solving proportions, we are going to be using cross multiplying to find the value of the variable in the proportion. So what we have here, let's start with A. So we're going to take A multiplied by 8 and then 12 multiplied by 6. So what you're going to have is two factors that are then equal to each other. So 8 times A gives us 8A, and 12 times 6 gives us 72. Now, where did these numbers come from? Well, when we cross multiplied, you have 8 multiplied by A. And since we have a number and the variable being multiplied, the variable always goes second in the term. And then you have 12 times 6. So that's where the 72 came from, and that's where 8A came from. We cross multiplied. Now, this is a little different than when we multiply fractions. When you multiply fractions, you multiply numerators times numerators, denominators times denominators. When you're solving proportions or cross multiplying to verify that two ratios or fractions are proportionate, you are literally multiplying across to form that x. You may have heard of this before as the butterfly method, or any other sort of different way to remember it. But basically what we're doing is we're cross multiplying here. So after you've cross multiplied, you're going to have two sets of factors, 8A and then the 72. And then from here, it's just a one-step equation solving for the variable. Since 8 and A are being multiplied, we use the inverse operation, which is division. And once we divide, we see that A is equivalent to 9. So that's all there is to cross multiplying. And all this is really just practice. Making sure that we're multiplying correctly, making sure that we're simplifying if we can. So for B, we have 30 divided by B equals 20 over 16. So again, cross multiplying, it's not going to be 30 times 20 because they're equivalent. So it's going to be 30 times 16 and B times 20. So we have B multiplied by 20. And that's going to equal, oh, that's not what I wanted. That's going to equal 20 times 16. Or 30 times 16, sorry, let's loop it there. Yeah, that's 30. That looks like a 3, right? So now it's just a matter of reorganizing it and simplifying any product. So we have 20b equals 16 times 3 is 48. And then since there was a 0 in one of the factors, I had a 0 at the end. So now we have 20b equals 480. And all that's left to do is solve for the variable. And in this case, we're going to use division to solve for the variable. So we divide both sets of factors by the coefficient, which is 20. Coefficient being the number next to the variable. The zeros will cancel out, leaving you a 48 divided by 2. So the variable has a value of 24. So cross multiplying is really not too terribly difficult. The goal here, is to solve for a variable, that will give us equivalent values there. Now, you might be wondering, well, why can't I just do what I did with equivalent fractions, right? Why can't I just find a factor that I can multiply, the numerator and the denominator by to get the same, to get an equivalent fraction? Well, equivalent fractions work when one of the terms is a multiple of the other term. So That's because then you're working with whole numbers. Obviously, you can do that. It'd be really tricky because you'd have to use fractions, mixed numbers, or decimals. And that's where it could get a little bit complicated. I mean, it's possible, but it's just complicated or more complicated than I feel than doing the cross multiply. So let's take this equivalent fraction, right? We have 3/8 equals, let's say, x over 16. So what we usually do is, well, why do I have to use cross multiplication when I know that 8 to 16 is just multiplied by 2, and I do the same to the numerator? So I know that x is 6, right? And that's absolutely correct. But let's look at problem C. To 21 to 15, 15 is not a multiple of 21. It's not. Now, 8 is a multiple of 16, so that's why we're able to multiply by 2 because, you know, they're common multiple. There's a multiple there. But 15 and 21, they're not, one of them is not a multiple of the other. Yeah, you could multiply by a fraction, or in this case with 21 divide by a fraction, but it's just going to be a little bit trickier, right? So how do you go from 21 to 15? Well, we're obviously dividing. We have to divide by a number that's larger than a 1 because 21 to 15 is smaller. So I think in this instance, you have to divide by what? 7 fifths? Yeah. So then you have to keep change reciprocate, cancel, then you get 15. You have to do the same thing here where you're dividing by 7 fifths. Keep change reciprocate. And 14, that's 10. So ultimately, would you get the same answer? Yes, but again, figuring out what that factor is going to be that you multiply by is what makes it a little bit trickier. So instead, we just cross multiply. 14 times 15, 21 times c. And if you don't want to multiply them, you don't have to because I'm going to show you why in a bit. You have 14 times 15, great. And then you have 21c, great. So now all that's left to do is just divide by 21. And here we can start canceling, right? So, we can simplify 14 and 21 by 7. So that's 2, that's 3. 15 divided by 3 is 5. And then 2 times 5 is 10. But again, you'll notice that we didn't have to do as many mental gymnastics when we cross multiplied as we did when we had to calculate what to divide or multiply by. So, could you still divide or multiply by an equivalent fraction or by a fraction equal to 1 to get the other fraction? Yes, you could, but I find it simpler to just cross multiply and divide. So 30 times d is 30d. 25 times 2.4 is, well, 2 times 25 is 50. 4 tenths of 25 is 10. 50 plus 10 is 60. And you divide both sides by 30. And that will give you a value of 2, which checks out because our answer makes sense. 30 is larger than 25. 2.4 is larger than 2. So you could always kind of look at how the given ratio is set up and see if that information matches what you just found. So here 30 hundredths equals n over 40. Since 30 is less than 100, less than half, n should also be less than half of 40. So we cross multiply. 30 times 40, which is, 4 times 3 is 12. We're going to add 2 zeros at the end of that. And that's going to equal to 100n. Divide both sides by 100. and then just some simple mental math where we cancel out the zeros. N equals 12, which checks out with what we originally were looking for, which was a number that's less than half of 40, and 12 fits the description. So then we have F. Last but not least, we have 12 times M, which is 12M. And then we have 100 times 9, which is 900. And I'll let you solve this one completely on your own. So a quick summary of solving for proportions. You're going to have essentially two ratios or two fractions that are equivalent to each other. We cross multiply to get two sets of factors that are equal to each other, and then you divide to solve for the variable. What we're not doing is we're not looking for equivalent. We're not looking for the factors that will make the fractions equivalent to each other. We're also not multiplying straight across. That is when we're multiplying fractions. In this case, we're not multiplying fractions. We are solving proportions. So slightly different. All right. If you found this video helpful, hit the like button and subscribe. Hope you have a great day, and we'll see you later.